So along with linear equations, we can have systems of linear equations. Now, what is a system of linear equations? It's just where I have more than one variable, and I also have more than one equation. So it's kind of like multiple equations, multiple variables, all having to hold true. So this would be something like, let's say my variables are x and y. Maybe I said x plus y equals 3, but also 2x minus y equals 1. That would be my system of linear equations. All the powers are 1, but at the same time, I have more than one variable and more than one equation. So that's a system of linear equations. So maybe we'll write that down over here. So a system of linear equations. So we have more than one variable, and we have multiple linear equations. And you can see I have that over here. I have two variables. I got my x and y, and then two linear equations. So the powers of all my variables are just 1. So how do you solve a system of linear equations? There are a couple ways. We're mostly going to do just one method, and that's going to be substitution. So what we're going to do to solve a system of linear equations, first thing you're going to do is take one equation and solve for one of the variables. It doesn't matter which one you choose. I would go with whatever one is going to be easiest for you. Use your thought process on this. Take one equation, solve for one of the variables. Next, plug in to the other equation. So from part 1, you're going to have one variable equaling something. Plug that into the other equation. 3, solve for that variable. And then lastly, solve for the remaining variable. So it's a lot of steps here, but I think once we do a couple, you're going to kind of see how this works. It's actually not that bad. So let's just do a couple. So first one, x minus y equals 0. And let's also say that 2x minus 4y, take that back, minus 2x minus 7y equals negative 3. So those are my two equations. I have two unknowns, my x and y. So what I'm going to do, take one of these equations, it doesn't matter which one, and solve for one of the variables. Now look at these two equations. Which equation is it going to be easier to solve for one of the variables? Probably this first one. Oops, x minus y equals 0. Now which variable do you want to solve for? I would say it's going to be easier to solve for x, to get x by itself. You don't have to, it's up to you. But if we just add y to both sides, what do we get? We get x equals 0 plus y, so just y. So I took my first equation and rewrote it. It's exactly the same equation. It's just rewritten in a different way. So I have x equals y. Now what was our next step? Plug this into our other equation. So everywhere I see an x in my second equation, so my second equation was 2x minus 7y equals negative 3. Everywhere I see an x, I'm going to plug in a y, because they're equal. So my equation is now 2y minus 7y equals negative 3. Now solve this for y. That's why we spent so much time on linear equations. Solve this for y. So 2y minus 7y, that's negative 5y's. Now what do? Divide by that negative 5, so I get 3/5. So now I know what y is. I'm halfway done. The only issue is my original problem had an x and a y, so you better figure out what x is, right? So how do I figure out x? We'll come back to that equation. X equaled y. So if I know x equals y, then I know that x is also 3/5. So there's my answer. X and y are both 3/5. Now is it true they're always going to be the same number? No. This was just kind of an easier one to start with, but solve for one variable, that was here, plug it back in to solve for the other one, so that's there. And you could go back and check. Is it true that 3/5 minus 3/5 is 0? Definitely. Is it true that 2 times 3/5 minus 7 times 3/5 is -3? With your calculator, yeah, it's true. Let's do another system here. How about 2p plus q equals 5, and also p minus 3q equals, let's go with 2. So here's my system of linear equations. All of the powers are 1. I have 2 variables, both linear. What am I going to do first? So I'm going to take one of these equations and solve for one of the variables. Now it doesn't matter which one you choose. I'm going to choose this one. In fact, if you want to choose the first one and solve for q and then check your answer, that's completely fine. So I'm going to choose this second one, which is p minus 3q equals 2. And I'm going to solve for p, because that's going to be the easiest one to solve for. So I'll add 3q to both sides. So I get p is 2 plus 3q. So I solve for one of my variables. Now what do I do with it? I'm going to take this and I'm going to plug it into my first equation. Why the first equation? Because this came from the second equation. They're the same thing, just rewritten different ways. So I have 2p plus q equals 5. I know that p is 2 plus 3q. So I'm going to replace p with 2 plus 3q. So there's my new equation. And this is a linear equation, just one linear equation, which we know how to solve. So I'll distribute and get 4 plus 6q plus q equals 5. And now what? I'm going to do 2 steps in one. So see if you can see what I did here. I'm going to subtract 4 from both sides, and I'm going to combine those two. So I get 7q equals 1. And then what? Divide by 7, so q equals 1/7. But that's only half of my answer. Remember, I have p and a q. So I'm going to come back up to this equation to solve for p. So p is going to be 2 plus 3 times 1/7. So that's 2 plus 3/7. So we'll just say 2 3/7. So those are my answers. I got q is 1/7, p is 2 3/7. So solving linear equations. We'll do one more, but solve for one variable, plug it into the other one, solve for that variable, and then go back to the original one. Alright, last one here. Let's do 3x plus 2y equals 5. And let's do x, take that back, not x. Let's do keep making mistakes here, 6x plus 4y equals 8. Yeah, this will work out well for us. So these are my two equations. Two equations, two unknowns. Take one, solve for a variable, and plug it in. Now, it doesn't matter which one you want to solve for, it's up to you. Why not take the first one? So I got 3x plus 2y equals 5. Which variable do you want to solve for? Doesn't matter. Might be easier to solve for y, but we'll see. So I'm going to subtract 3x and get 2y is 5 minus 3x. And then what? I got to divide by 2. So y equals 5 halves minus 3 halves x. So there's my equation for y. Now what am I going to do? I'm going to take this, I'm I'm going to plug it back into my second equation. So 6x plus 4y equals 8. Everywhere I see a y, I'm plugging that in. So I got 4 times 5 halves minus 3 halves x equals 8. Now let's solve this. So first I'm going to distribute my 4. So 4 times 5 halves is 10. If you don't believe me, you can use a calculator for that. What else do I have? 4 times 3 halves is 6. And that's still going to be 8 over there. Okay, so let's kind of step back for a second and look at what we just did. First thing we did, took the first equation, solved for y. That's nothing new. Took that, plugged it into the second equation, and now I've reduced it down to here. Look at the left-hand side and tell me what's happening. I have 6x plus 10 minus 6x. Well, those are going to go away, and I have 10 equals 8. Now, is that true? Is 10 equal to 8? Definitely not. So, since I got an equation that is not true, what we say is that our original system, so this system here, has no solutions. So whenever I reduce it down and get a statement that's never true, we say it has no solutions. Now it is possible to have infinitely many solutions. That's where you get something that's like 8 equals 8 or something like that, but it is possible to have no solutions, one solution, or infinitely many. Those are your options. But it's still the same process. Take an equation, solve for one variable, plug it in, solve for the other variable, and then go back.